Hi everyone and welcome. This is our Signals and Network Systems project on audio signal processing in MATLAB. I am Gaurang Sangrolkar and my teammate is Abhimanyu Sa. We are from Sardar Patel Institute of Technology, Andheri, Mumbai, branch Electronics and Telecommunication Engineering. So, what's this all about? Our project takes a standard audio file, uses MATLAB to mathematically process it, and creates three distinct classic audio effects. We will be showing you how we made a robotic voice, an echo, and a speed change. In this video, we will first give you a live demo of all the effects, then Abhimanyu and I will do a complete code breakdown line by line and connect our script directly to the core theories we have learned in our signal and system classes. Alright, we are here in MATLAB. Before we dive into the code, let's hear the results. शर्मा जी, इसी बात का तो गम है कि सैकड़ों करोड़ों बार समझाने के बावजूद फकरुद्दीन खान फिर से फालतू की अफवाहें फैलाने लगा है। वो जाहिल जलील आदमी हमारी दोस्ती के काबिल तो कभी था ही नहीं। शर्मा जी, इसी बात का तो गम है कि सैकड़ों करोड़ों बार समझाने के बावजूद फकरुद्दीन खान फिर से फालतू की अफवाहें फैलाने लगा है। वो जाहिल जलील आदमी हमारी दोस्ती के काबिल तो कभी था ही नहीं। शर्मा जी, इसी बात का तो गम है कि सैकड़ों करोड़ों बार समझाने के बावजूद फकरुद्दीन खान फिर से फालतू की अफवाहें फैलाने लगा है। वो जाहिल जलील आदमी हमारी दोस्ती के काबिल तो कभी था ही नहीं।
शर्मा जी, इसी बात का तो गम है कि सैकड़ों करोड़ों बार समझाने के बावजूद फकरुद्दीन खान फिर से फालतू की अफवाहें फैलाने लगा है। वो जाहिल जलील आदमी हमारी दोस्ती के काबिल तो कभी था ही नहीं।
The script has generated this 4-panel plot showing the original signal and our 3 new effects. So, how did we do this? Let's break down the code. Step 1 is simple, loading the audio. We use the audio read function which gives us two variables, audio, which is the signal data itself, and fs, the sampling rate. The sampling rate fs is critical. It tells us how many data points or sample were recorded per second. We also convert the audio to mono and take just the first 15 seconds. My part of the project was creating the robotic voice. This technique is called ring modulation, which is a form of amplitude modulation. The theory here is multiplying two signals in the time domain causes their spectra to convolve in the frequency domain. We create a simple carrier signal, which is just a 120 Hz sine wave. Then we perform an element by element multiplication of our audio signal with this carrier. This multiplication creates new high frequency sidebands, which gives the voice that classic metallic robotic structure. We then use a low pass filter to clean it up. You can see in the plot how the original waveform has been completely reshaped by the fast moving carrier wave. Our next effect is echo. An echo is just a delayed, quieter copy of the original signal. This is a perfect example of digital filter. Specifically, this is a finite impulse response or FIR filter. We first define our delay of 0.3 seconds and convert that to a number of samples using our sampling rate fs. Then, this for loop creates the new signal for every sample. It takes the original shape and adds a fraction, which we call alpha, of the sample that happened delay samples ago. This creates the echo, and because it only uses past input samples, it's a classic FIR filter. Now, I will hand it over to Abhimanyu to explain the next effect.
My final part of the project was changing the speed and pitch. This is achieved using a process called resampling. The resample function in MATLAB is incredibly powerful. We can set a speed factor of 1.5. This tells MATLAB to increase the number of samples in the signal, effectively stretching it out. When this new longer signal is played back at the original sampling rate fs, it sounds slower and as a result the pitch also drops. If we had used a factor less than 1, it would speed it up. So that's how our project works. As for the future, this project could easily be expanded. We could build a MATLAB app designer or GUI to control the echo time and carrier frequency with sliders. We could also adapt the code to process live audio from a microphone in real time or even combine these effects to build more complex ones like reverb or a flanger. This project was a great way to see how the math from our signals and system class can be used to build real world audio tools. Thank you so much for watching. This project was by me, Abhimanyu Shah, and Gaurang Sangrulkar.